close your eyes for a second.
Now imagine you're falling. Not off a building, not into water, into a black hole. Everyone assumes you'd see darkness, or fire, or some cosmic mouth swallowing you whole. You wouldn't. The last thing you would ever see isn't inside the black hole at all. It's everything outside of it. The whole universe, all at once. And by the end of this video, you'll understand exactly why.
Black hole mergers define our
Orphan black hole that devours stars.
The laws of nature to explain black holes.
This thing doesn't glow. It doesn't burn. It doesn't even have a surface you could touch. And yet, it's the most violent object nature has ever built. This is a supermassive black hole, millions of times heavier than our sun, packed into a space that shouldn't be able to hold anything at all. It's so dense that gravity itself turns into a trap. Even light, the fastest thing in existence, can't climb back out. Movies love to show black holes as giant vacuum cleaners, sucking in everything nearby. That's not what's terrifying about them. What's terrifying is how quiet they are. Let's send someone in, just for the sake of understanding this. One astronaut, no rescue ship behind her, no backup plan. This is a one-way trip, and she knows it.
Distance to event horizon, 500 kilometers.
Copy that. Beginning final observations.
As she gets closer, something strange starts happening to the stars behind the black hole. They begin to bend, not because they're moving, but because space itself is bending. This comes straight from Einstein's General Relativity. Gravity isn't really a pull, it's a curve. Picture a bowling ball on a stretched rubber sheet. Everything nearby rolls toward it. Now make that bowling ball weigh 4 million suns. That's what space is dealing with here. And here's the part that catches everyone off guard. There's no wall, no portal, no giant mouth waiting to swallow the ship, just silence. The event horizon isn't something you can see, touch, or crash into. It's simply the point in space where turning back stops being possible. Physically, permanently impossible. Quick physics detour, because this is the part most people get wrong. Throw a ball harder, it goes higher. Throw it fast enough, and it escapes Earth's gravity completely. That speed is called escape velocity. For Earth, it's about 11.2 kilometers per second. Near a black hole, escape velocity climbs past the speed of light itself. And since nothing in the universe can outrun light, not even light can escape. That's the whole reason a black hole looks black. It's not empty, it's a place where the exit door requires a speed that doesn't exist. 100 kilometers out, and the view outside stops making sense. The stars aren't disappearing, they're multiplying. The entire universe seems to wrap itself around the black hole until she can see galaxies in directions that shouldn't even be visible from where she's sitting. This isn't an illusion, it's called gravitational lensing. The black hole's gravity bends light from every direction at once, turning the space around it into a giant cosmic mirror. Good luck.
What happens after I cross?
No one answers her, because no human has ever crossed an event horizon, and no message has ever come back. 5 kilometers. 4, 3. The stars grow brighter than she's ever seen. The universe bends around her, and just before she crosses the point of no return, she sees something no human being has ever witnessed. The entire universe reflected around a perfect circle of darkness, but that's only the beginning. Here's where it gets genuinely unsettling. She crosses it, and nothing happens. No explosion, no flash, no impact.
Did we just cross it?
If the black hole is big enough, you might not even feel the moment you cross the event horizon, because it was never a wall. It's simply the last place in the universe from which anyone could still hear you.
Everything still looks...
Oh no. Not because the radio broke, not because she stopped talking. Every radio wave she sends now is trapped inside the black hole with her. That was the last message the universe will ever receive from that ship. Now, two completely different stories start unfolding at the same time. From mission control side, the ship appears to slow down, slower, until it almost freezes at the edge. Its light turns redder, dimmer, and eventually fades out entirely, as if it never crossed at all. But inside the ship, she notices nothing strange. Her clock ticks normally, her breathing is normal, her heartbeat is normal. This is one of Einstein's strangest predictions. Gravity doesn't just bend space, it bends time. To her, only minutes pass. To the universe outside, it could be years, centuries, even millions of years. If she could somehow survive long enough to watch, she'd see the future of the universe play out in front of her eyes. Stars igniting and burning out, even our own Milky Way eventually colliding with Andromeda, all while her own watch barely moves. But now the black hole shows its real power. She feels a pull, not evenly, but starting at her feet, because her feet are just slightly closer to the black hole than her head. That tiny difference in distance means gravity is pulling harder down there than it is up top. Scientists actually gave this a fittingly ridiculous name, Spaghettification. Sounds like a pasta dish. It's actually one of the most violent effects in physics. The body stretched continuously, longer and thinner, until the forces become impossible to survive. So, what's the actual last thing you'd see falling into a black hole? It isn't darkness, it isn't your own ship, it isn't even the black hole itself. It's the entire universe, every galaxy, every star, millions of years of cosmic history, compressed into a single, brilliant ring of light, wrapped around a perfect circle of nothing. At the center of every black hole, physicists believe there's a singularity, a point where our laws of physics simply stop working. This is where Einstein's equations run out of answers. Maybe space ends there. Maybe time does. Or maybe something we don't have a name for yet is waiting on the other side. Until we find a theory that unites relativity with quantum physics, the inside of a black hole stays exactly what it's always been. One of the last true mysteries in the universe.